Okay, in this video, we're going to determine all points on the graph of this function for which the tangent line is horizontal, B, the tangent line is slope -1. This is from Openstax Calculus Volume 1. It's section 3.3. So let's start on part A. So here's our solution. So for part A, well, I'll just make this note. The tangent line is horizontal when f prime of x is equal to 0. Why is that? Because the derivative, f prime, is equal to the slope of the tangent line. All right, so the derivative is the slope, and a horizontal line has slope 0. So the derivative is found using the power rule. So here's our, the function sitting right up here. And I'm going to use the power rule to find the derivative. So I have 3x squared plus 2x minus 1 minus 0, I suppose. And then I'll solve by setting this whole thing equal to 0. And I think that I can factor this without using the quadratic formula. 3 is a prime number, so the only choice really is 3x times x. You could have x times 3x, but it'll be the same. But then the next part is a little more tricky. Maybe it's plus 1 and minus 1. I mean, 1's a prime number, so that's, if it is going to factor, it's either going to be -1, +1, or 1, -1. What I mean is if it's going to factor over the integers, or actually, yeah, okay, I think that's correct what I just said. Then there you go. So then we get 3x minus 1 equals 0. So 3x equals 1, x equals 1/3, x plus 1 equals 0, x equals -1. And do I have the point? When it says points, it seems to mean that I should find the y coordinate, and that's the part I sort of don't want to do. So it's not so clear when they say points whether they mean the y coordinate also. Sometimes they just mean the x coordinate, and that to me is actually a little bit maybe the harder part, because I don't want to do fractions, but and then okay, well, but I think I can do it. I don't like it when I did all this calculus and then I get this part wrong, which, I shouldn't, I guess not. It's -32/27, so we have f of 1/3 is equal to -32/27. That's 1 point. And then the other one, or maybe I should write 1/3 -32/27. Maybe that's the way to do it. And then the next one is f of -1 is -1 to the 3rd power plus -1 squared minus -1 minus 1, which is -1 plus 1 plus 1 minus 1, which isn't that 0? Okay, so the next one would be -1, 0. Well, make sure you put it back into the original function. Yeah, okay. So let's do B. The tangent line has slope -1 when f prime of x equals -1. It looks like that's going to require more space. So I'll add a page there. Okay. So we already did the derivative. I mean, I don't need to do that again, right? We don't want to no, we don't want to double up on our work. Okay, so now I'm going to have 3x squared plus 2x minus 1 equals negative 1. So that gives 3x squared plus 2x equals 0. I think I can factor that. I have a feeling, again, I'm going to be mostly challenged by the fractions if I have to plug this in. I think points possibly means just the it just means the x values possibly, but because we don't have, there's an even problem, there's no solution. Oh brother. Okay, let's just check this out. Okay, so there's no solution, just an even problem. I mean, there's no solution in the back of the book. So I just wanted to see what they're going to do there. But while I'm complaining about that, I can just go ahead and get the answer. But anyway, there's no solution in the back of the book. They don't give the solution. There's an answer to this, but it's not shown in the back of the book. Okay, negative 2/3. Let's see how much I can make a mess of that. Oh my gosh. Fractions. I guess I can't imagine any of these great scientists complaining about fractions. Einstein probably just do this in his head very immediate. I don't know. Just me, maybe. But I think I've heard people say they don't like working with fractions. Okay. Negative 8 plus 12 is 4, plus 18 is 22, minus 27. Seems like it could be this. I feel like I need to double check. I just double checked in my head, but okay, so negative 2/3, negative 5 over 27. Okay. Alrighty, so that was part B. So for the first part, we took the derivative and we want to find out where the tangent line is horizontal. So we take the derivative and set it equal to 0, and that turned out to be a factoring problem that was not, it wasn't super easy, but it was doable. And then you solve for x. You get x is 1/3, x is negative 1. Those are where the derivative is equal to 0. If I put those numbers into the derivative function, if I did it right, which I think I did, then it's going to equal 0. Then I found the y coordinates. Wasn't sure if I had to do that. The next we wanted to find out where the tangent line has slope negative 1, so I take the derivative, set it equal to negative 1, and then that actually turns out to be a really very simple factoring problem. Got x is 0, x is negative 2/3. Then I found the y coordinates. So that's that. Goodbye.